You've studied for months for your Biology 9700 exam, you know the content inside out, yet right here on a standard question about immobilized enzymes and alginate, you just hemorrhage marks. It's one of the most misunderstood and, frankly, harshly graded areas in Cambridge biology. And it's not because the science is too hard. It's because of a fatal error in how answers are structured. So let's fix that right now in this explainer. Look at this. Can you spot the fatal error here? It's a tiny, almost invisible mistake in a typical student answer. It's a trap, and it destroys your grade boundary before you even realize what hit you. You know, most students walk out of the exam hall thinking they absolutely nailed this, only to see a 0 next to their answer. Let's see if you can catch it. Okay, check out this comparison. Up top, we have a really vague, generalized answer. The enzyme works better because it's trapped. I mean, it sounds logically okay, right? But compare that to the bottom. Immobilized lactase maintains a higher rate of reaction at 45 degrees Celsius because the alginate matrix prevents thermal denaturation. Now, this is a real game changer because it exposes the most costly mistake you can make. That first answer ignores the specific context and completely forgets to use precise units or defined terms. And examiners, they ruthlessly penalize this. If you are vague, you bleed marks. Simple as that. Section 1. Core Principles and Terminology. So, how do we actually build that required precision? Well, principal examiner reports highlight a consistent, really devastating confusion of key terminology in this exact topic. Let's look at the absolute foundation of the mark scheme. The critical rule is this: always define key scientific terms clearly before using them in an extended response. Top-performing students absolutely must demonstrate what Cambridge calls connected conceptual understanding. You can't just throw around terms like alginate matrix or active site without establishing the baseline context. You have to prove to the examiner that you actually know what the words mean in the context of the experiment before you build an argument around them. Okay, let's break down the top 3 examiner warnings, pulled directly from Cambridge reports. These are straightforward, but man, are they deadly. Number 1, answers are just too vague. Saying it's faster or it's better will score you absolutely nothing. Number 2, a complete failure to check units and terminology. Look, if the graph is in millimoles per minute, your answer better say millimoles per minute. And number 3, ignoring the specific context provided. If the question is about, say, continuous fermentation of milk, your answer must reference milk, not just some generic enzyme reaction happening in a vacuum. Section 2, the method mark strategy. Now that we know exactly what not to do, let's look at how to actually secure those points, even when a complex calculation trips you up. The standard sequence guarantees process marks. Number 1, identify key elements from the text. Number 2, apply relevant principles. 3, execute your analysis with very, very clear working. 4, always verify the results. And 5, present it in the appropriate format. By following this systematic processing, you secure marks for your logic during complex problem solving. So even if your final calculation is slightly off, this step-by-step working is your safety net. It proves you understand the biology, and examiners will absolutely reward you for it. And you know, part of that systematic processing often involves data. You must know exactly which statistical test to execute during data interpretation to satisfy the examiner's rigorous standards. We have the t-test for comparing the means of 2 sets of data. We have chi-squared for categorical data, like when you're observing expected versus actual phenotypes, and correlation tests to find relationships between 2 continuous variables. Picking the wrong test here, that's an automatic loss of methodology marks, no way around it. In a moment, the examiner's clue that changes the answer completely. Seriously, I'm going to show you a hidden signal in the exam paper that dictates whether you get full marks or a big fat 0. But first, we need the framework that makes that clue obvious. So let's keep building. Section 3, fixing flawed student answers. Let's escalate the difficulty a bit and apply our systematic framework directly to a Cambridge-style comparative analysis question. Let's deconstruct a flawed student answer against a top band response. Up top, the flawed answer. Immobilized enzymes can be reused, but free enzymes cannot. I mean, sure, it states a fact, but look at the improved top band answer right below it. Whereas free enzymes are lost in the product, immobilized enzymes are retained in the alginate beads, allowing for continuous reuse and significantly lowering downstream processing costs as shown in Figure 1. Do you see the difference there? Higher order assessment objectives demand that you evaluate alternatives and justify your conclusions. You absolutely need comparative connectives like whereas, and you must link it directly to specific evidence. To make this totally foolproof, use this comparative analysis checklist.
First, identify similarities and differences. Students almost always forget the similarities. Next, use comparative connectives to bind those points together. Then support those comparisons with hard evidence from the provided data or graphs. And finally, draw conclusions on their relative importance. If you systematically check these 4 boxes, you're extracting literally every single mark available in an evaluation question.
Section 4. Critical examiner warnings. But what happens when the exam throws a completely unfamiliar experiment at you? Examiners ruthlessly grade experimental skills and problem-solving elements. So here is how you handle those practical investigations and spot data anomalies. It's a simple deconstruct, solve, evaluate loop. Step 1, identify the given information. Step 2, break the experiment down into logical steps. Step 3, solve systematically. Step 4, always pause to check for reasonableness, like, does this anomaly actually make sense biologically? And Step 5, make justified recommendations based on the data. If you follow this loop, no unfamiliar context or strange data set can ever panic you again. Okay, here is that crucial payoff I promised earlier. The clue, the command word, dictates the entire mark scheme. This is absolutely critical. Knowing the biology of immobilized enzymes is really only half the battle. The specific command word, whether it's describe, explain, evaluate, or calculate, dictates exactly how your knowledge must be formatted. If it says describe and you explain why something happens, you get 0 marks. The command word is the hidden key to the whole shebang. Section 5. The final diagnostic challenge. Let's put this to the ultimate test. It's time to put on your examiner lens and see if you can spot the tragedy here. Why did this scientifically accurate, perfectly calculated answer score absolutely 0 marks? Read it carefully. The biology is flawless. The understanding of alginate beads? Perfect. But the prompt asks the student to evaluate the use of immobilized enzymes compared to free enzymes using the data provided. The student only explained the science. They didn't reference a single data point from the table, nor did they weigh the pros and cons. They completely misunderstood the hidden command word and the requirement for data, and that resulted in a tragic 0. This is exactly why you need to master these hidden exam signals. If you want to stop bleeding easy marks, you must understand exactly what Cambridge is asking you to do. So subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Our next explainer diving deep into exactly how to decode every single command word is the absolute mandatory cure for the 0 mark tragedy we just witnessed on screen. So as you review your notes tonight, I want you to ask yourself, are you actually answering the question the examiner asked, or just the one you wished they did?